Alright, today we're going to continue on with 2.3 and 2.4, talking about polynomials, synthetic division, long division, and complex numbers. Today we're going to focus more on the complex numbers, but we're going to start off with the polynomial division first. So we want to show, or I want you to show that x equals 2 minus root 5 is a solution to the equation x cubed minus x squared minus 13x minus 3 equals 0, and I want you to find the remaining solutions. Some hints down here that might help you is recalling that the sums of solutions is the opposite of b over a when we're talking about a quadratic equation, and the product of solutions is c over a when we're talking about a quadratic equation. So pause the video, show that this is a solution and find the remaining solutions, and then unpause it when you're ready to check your work. Okay, so one way to show that this is a solution is we can do synthetic division with 2 minus root 5, and you can see my work here. I end up with 0 as a remainder, and so yes, I know that it is a solution. Now the resulting quadratic is x squared plus 1 minus root 5x minus 6 minus 3 root 5. That's a little bit difficult to work with, to try and factor. So now I'm going to go with the understanding that the original polynomial has rational coefficients, so I know for a fact that 2 plus root 5 also must be a solution. So remember, whenever we end up with irrational solutions, so for example 2 minus root 5, I know that if the original polynomial has rational coefficients, that the conjugate of this solution has to also be a solution. So now I'm going to use my knowledge of the sum of the solutions and the product of the solutions. So I know 2 minus root 5 plus 2 plus root 5 is 4, so I know that's the opposite of b over a, so I know b has to be negative 4, because 2 minus root 5 times 2 plus root 5 is negative 1, so c has to be negative 1. Now I also know that I know a has to be positive 1 because, again, in the original polynomial, the leading coefficient is 1. Therefore, all of the factors of it also have to have a leading coefficient of 1. So I know the x squared minus 4x minus 1 is a solution. This is the product of x minus 2 minus root 5 times x minus 2 plus root 5. So another way in which I could have gotten this is to multiply those out. Now to find the third solution, I did long division with x squared minus 4x minus 1, and you can see my work here. I ended up with a remainder of 0, and I got x plus 3 as a quotient. Therefore, x equals negative 3 is my solution. So my three solutions are x equals negative 3, x equals 2 minus root 5, and x equals 2 plus root 5. I also showed you down here using that trick of synthetic division that I showed you before in class. So if you use that trick, then I'm going to use the coefficients of 4 and 1, and then you can see my work here. And again, I still get the x plus 3, so I get x equals negative 3 is my solution. Okay, so now we're going to start talking about complex numbers, but in order to understand complex numbers, we need to understand the imaginary part of the complex number, and that's our unit I. Now, imaginary is not really a good word because it makes it seem as if it's just made up or fake, but it's not. It's just the phrase that we came up with. I don't know where it comes from, but it's easy to remember because I is the unit that we use for it. So we want to understand that, or hopefully we understand, the square root of negative 1 is I. So this is where we get I. And now from here, we want to make sure we know that I squared then would be negative 1. I cubed we can think of as I squared times I to the first. So this would be negative I. And I to the fourth we can think of as I squared times I squared, which would be 1. And then this cycle repeats every power of 4. So I to the fifth would be I to the fourth times I, which is just I. We're never going to go the other way. So if we have I, we're not going to write it as the square root of negative 1. Whenever we have the square root of a negative, we bring the I out from that square root. So this idea of powers of 4 helps us evaluate I to higher powers. So if I have I to the 26th, I to the 137th, and I to the 215th, it makes it very easy for me to evaluate these if I think in terms of 4. So for instance, if I say, well, how many times does 4 go into 26? Well, I know that it goes in there 6 times. So I can rewrite this as I to the 4th to the 6th power, and then what am I left over with? Well, I'm left over with I squared. So I know that this is going to equal -1, because this is the same as I squared. So pause the video, take a minute, and figure out what is I to the 137th and I to the 215th. Okay, so hopefully you figured out that I to the 137th is the same as I, and I to the 215th is the same as -I. Alright, now we're going to go on to talk more specifically about the complex number. So the standard form of a complex number, and this came up in some of our previous examples earlier, is the form a plus bi, where a is the real part and bi is the imaginary part. Now we want to understand complex numbers are our largest number group that we deal with. All real numbers are included in complex numbers, they just have a 0 as the imaginary part. The complex conjugate, so hopefully remember what a conjugate is. So if I have a plus bi, then the conjugate would be a minus bi. And vice versa. If I have a minus bi, the conjugate is a plus bi. Well, the nice thing about using conjugates with complex numbers is similar to when we have conjugates with irrational numbers, and that is if we multiply the conjugates together, then the imaginary part is going to go away. So if I do a plus bi times a minus bi, this is going to equal a squared plus b squared. So we can see in this product then that the imaginary part is gone. Now, principal square root. So this is a definition we're going to look at. So this is telling us if a is a positive number then the principal square root of the negative number which I'll write as negative a, is the square root of negative a equals the square root of a times I. And that's what we want to understand, that anytime we have the square root of a negative, we want to pull the I out first before we do anything else with that root. So this leads us to a side note of understanding that idea that we have to pull the I out first. So note we know normally we can write, if I have the square root of AB, this equals the square root of A times the square root of B. Well, this is only true if A and B are positive. So this is not valid for A is less than 0 and B is less than 0. because if a and b are negative, we have to pull the I out first for each one before we can combine them into a single product. Okay, so I want you to practice multiplying and combining the real and imaginary parts here and write it in standard form. So pause the video, do that, and unpause it when you're ready to check your answer. Okay, so first I'm going to multiply this out using the distributive property. I get 1 minus 4i plus 4i squared, and then I'm going to multiply this out. Notice I kept the parentheses here so that I remember to distribute that negative. Multiplying this out, I get 1 plus 4i squared. I squared is negative 1, so this becomes a negative 4. This became a negative 4, but then when I distributed the negative 1, it became a positive 4. So I end up with 1 minus 4i minus 4 minus 1 minus 4i plus 4. The 4, the negative 1, and the 1 cancel, and I'm left with negative 8i. I could write it as 0 minus 8i if I want to. Either one is correct. I don't need to write the 0 in there because it's 0, but just to point out that that is still a complex number. Okay, now let's look at division. So our goal with division is to get rid of the complex number in the denominator and then write in standard form. So the way we're going to do that is multiply the top and the bottom by the conjugate. So pause the video and try to write this in standard form, and then unpause when you're ready to check your answer. Okay, so if I multiply the top and the bottom by the conjugate of the denominator, I end up with 6 plus 5i minus 14i squared. Remember, I squared is negative 1, so this becomes a positive 14. So that's how I got the 20 down here, because I did 6 plus 14. 1 minus 4i squared, this becomes a positive 4, so that's how I end up with a 5 in the denominator. Now, for this problem, I did not have to show this middle step here, but I wanted to make sure we understand that no matter whether the coefficients in the numerator actually divide by the denominator, I still need to split this up into two separate terms because I want to write my answer in standard form. And so in this case, they both simplify, so my answer is going to be 4 plus I. Alright, one more of these. So I want you to simplify and write this in standard form. So pause the video, do that, and unpause when you're ready to check your work. Alright, so assuming I did my math correctly here, first thing I did was get a common denominator. Now, you could have multiplied the top and the bottom of this term by 4 plus I, and the top and the bottom of this term by I, or negative I first, to get rid of the i's in the denominator. That might be more work, it might be less work. Depends on how the problem works out. I chose to get a common denominator first, so multiply the top and the bottom of this by I, the top and the bottom of this by 4 minus I. When I did that, the numerator simplified to just 5, and the denominator became 1 plus 4i. So now I multiplied by the conjugate of the denominator, and I end up with 5 minus 20i over 1 minus 16i squared. 16i squared is negative 16, but since this was already a negative, it became positive. So 1 plus 16 is 17. And then I split this up into two separate terms to show the real and the imaginary part of the complex number. Alright, now let's switch back to polynomials. So here is a picture of polynomial function. I want you to write an equation for this graph. There are many correct answers, but there are certain things that you have to have in that answer. You do not need to multiply out your equation. You can leave it in factored form. So pause the video, write an equation, and then unpause the video when you want to check your answer. Okay, so the answer that I came up with is f of x equals x squared times x minus 3 quantity cubed. Now, how did I come up with that? Well, first let's look at the end behavior. Well, the end behavior is down, left, up, right. So I know it has to be an odd degree with a positive leading coefficient. Now let's look at the zeros. The zeros are x equals 0 and x equals 3. But I know at x equals 0 because it touches and bounces back that it has to have an even multiplicity, and because it goes through the 0 at x equals 3, it has to have an odd multiplicity. I can see visibly 4 turns, so 1, 2, and then 3 and 4 turns, therefore it has to be a minimum of a 5th degree polynomial. So that's how I came up with my answer here. X squared is the 0 x equals 0 with an even multiplicity. X minus 3 cubed is an odd multiplicity, and 2 plus 3 is a 5th degree polynomial. So we're going to stop this video here, and then we'll have a part 2 to do a couple more examples.